Alrighty, guys, so let's get into our algebra. So the first thing that we're going to do is we're just going to recap some important terminology. And those of you that joined early and you saw my emoji, terminology is so important, because if you get asked questions and you don't actually understand the words that are being used in the question, it makes it very hard to answer it. Okay, so unfortunately, it is just, oh, I'm going to sneeze, sorry. Oh, sorry, grade 8. Unfortunately, terminology is just one of those things we have to get used to. Some schools and some teachers even like to ask you, give the definition for constant, coefficient, whatever. So it is very important you know these words. So the first term or the first word we have to understand, especially in algebra, but in maths in general, is what a term is. Okay. So terms, if we go back to this idea of maths being a language, terms are parts that make up our expression. So you can almost think of terms as the words that make up a sentence, your sentence being an expression. So for example, you could have 3x to the power 4 plus 2x, that's weird looking, 2x cubed minus 7x plus 5. Each of those individual terms are making up an expression that I work with. What you also need to remember is that terms are separated by plus and minus signs. And so what that means is, in this expression that I've written down, every time you see a plus or minus sign, you just need to bear in mind that it is likely separating terms for you. And so in this very first expression, I have got 1, 2, 3, 4 terms in my expression. Sorry, I don't know why I made a choice of a glittery rainbow pen, but anyways, we're just going to roll with it. So there are 4 terms there. I know there's 4 because the plus and minus signs are separating my terms for me. And that is what makes up my expression. So that's the very first important thing that we need to know, mostly because as we start to simplify, you're going to see that you can't start adding or subtracting values until you have simplified individual terms. And if we don't do that, we are not following the correct order of work or the correct bodmas steps in our expressions. Right. Vishali, I appreciate the contribution there on the chat. So just quickly, guys, when we have expressions, we talk about expressions as being polynomial. So the general word for an expression is a polynomial. Basically, that means multi-termed expression. We've got special names for 1, 2, and 3-termed expressions. 1 is a monomial, 2 is a binomial, 3 is a trinomial, 4 or more, we just say polynomial, otherwise it gets a bit complicated. So this is a polynomial in this case. Olonda asked, what about times or divide? Olonda, those don't separate terms. Those come into our bodmas where we first need to deal with multiplication or division or exponents before we start looking at the term. So before we start looking at the addition or subtraction in order to simplify. All right, so guys, quickly on the chat for me, can someone tell me what a constant is? So on the chat, what is a constant? No one. Remember, we only raise hands until when I ask you to raise hands. You can give examples if you want. Please only raise your hand when I ask you to raise your hand, grade 8. Okay, good. We've got some good definitions here. So a constant, and I like this idea of rules and stuff, but if we just break a constant down to its very basic meaning, it means it doesn't change. So a constant term, if we are looking now specifically at expressions, is a term whoops, that has no variable. Now remember, a variable is a letter. And the reason this makes it a constant is because a variable represents something that we are either multiplying or dividing a value by. And so if a number has no variable attached to it, I'm not multiplying or dividing it. I'm not in any way changing its value. And so what that means is anytime we see a term with no variable, we are working with a constant. So if I go back up to the expression that I wrote down, my constant here would be positive 5. That is the only term in my expression that does not contain a variable. It cannot be changed by a multiplication of the value x. If I now said x is equal to 2, that's going to stay 5 because it contains no variable. I'm not going to multiply or divide it by whatever x's value is. So again, a constant is a term that has no variable. It can't be changed. It remains exactly the same. Okay, so those are terms. That's a constant. The next very important terminology or word that we need to know is coefficient. So coefficient, firstly, the way we identify coefficients are the numbers in front of your variables. Right, and what we need to remember is that because it's sitting right in front of your variable, you are generally multiplying the variable by that number. So again, if I look at the example of the expression that I wrote at the top, and I ask for the coefficient of, let's say, for example, x to the power 4. If we go to our term of x to the power 4, which is our very, very first term, we are looking for the number in front of it. We are looking for the value that it is being multiplied by. And so in this case, its coefficient is 3. All right,
take screenshots, everyone. Sorry. Just reminding them to take screenshots.
Yeah, guys, do take screenshots. I've got one more term that I want to talk about, so I will make it a bit smaller so you guys can screenshot everything. But a coefficient is the number that sits in front of your variable. And remember that we are multiplying the variable by the coefficient. So for example, 3x to the power 4 is saying 3 times x to the power 4. There is an operation between your variable and your coefficient. It is multiplication. All right, and then the last one, I hate this definition because, like, why? But we do need to know it. The last definition we have here is degree. So the degree of an expression basically is asking you to look at the highest or the biggest variable exponent. I'm going to start my sentence again, and apparently my writing is the highest or the largest exponent that you are dealing with in your expression. Now, this does become quite helpful. Yeah, this does become quite helpful when we start working with equations, because knowing the degree of your expression also gives you an idea of how many answers you should be getting from an equation. So for example, if your highest exponent is 2, so x squared, you should be getting 2 solutions to an equation that has x squared in it. If it was x cubed or x to the power 3, in an equation, you should be getting 3 solutions for x if you have x cubed in it. So it is quite helpful as we start to deal with other sections and start to sort of combine our knowledge. But the degree is the largest exponent or power of your expression. So again, if we use the same expression that we've been working with the entire time, the degree of my expression here is the one with the highest exponent. So my degree here is 4. That is the largest exponent that I have for the x variable. And so here, my degree is 4. So if I were to make this an equation, I should be getting 4 solutions for x. That is sort of one of the ways that the degree can help us when we start talking about different parts of algebra. Right, so I'm going to let everyone take a screenshot of those 4 important terms that we've just spoken about. While you are taking screenshots, if anyone has any questions, now is the time where you can raise your hand and ask your questions. Otherwise, we're going to start having a look at some examples. BK? I remembered from Saturday.
Yeah, you remember, yeah. Ma'am, so for example, ma'am, I'm still in the terms, ma'am, right? Like, how can you, like for example, if there's brackets and stuff, if there's brackets, how do you know if there's terms?
Okay, so my first question to you is, what operation do brackets generally mean? Like, what operation do we generally use with brackets?
Times.
Okay, good. So because brackets generally indicate times, it means it's probably still going to be one term. So for example, if we had something like 3 times x plus 2 minus 4x squared minus, I don't know, 1. Because that between the 3 and the bracket is a times, that entire thing is one term because the whole thing is 3 times a value. Then this minus sign over here, come on, is separating those 2 terms. So here's my second term. And then finally, that minus between the negative 4x squared and the 1, so over here, that is separating my terms again to get my third term. So when there's brackets, because that means times, it is still one whole term. It is only if I've got a plus or a minus that my terms are being separated.
Oh.
Okay, so inside the bracket, if I now go into the bracket that I wrote down there, I've got 2 terms inside this bracket. But if I look at this sort of term as a whole, that is one term because it's multiplication. Does that make sense?
Yes, ma'am.
Good, BK. Right, reminder grade 8s, I'm not re-explaining anything. Unfortunately, if you were late, you were late. If you are confused about something, you can ask a very specific question and I can help you just like BK did. But unfortunately, if you were late, you need to go and watch the recordings. Or Tile?
I'm going to definitely enable the waiting room now.
I wanted to ask, how do we multiply numbers of the same base?
Okay,
using
using that?
Using the point of the coefficient and constant, how we multiply them. For example, if I had the number 3x squared multiply by 3xy.
Okay. xy
how
squared.
Would we, yes. How
like
would
that.
we multiply or add that?
All right, so this is going back to our exponent section. So I'd encourage you to go and look at the exponents videos. But basically, when we're timesing this, we deal with, like you were saying, like, I don't want to say like terms because that's not what they are, but we deal with things that are similar. So firstly, I'm going to deal with the coefficients. 3 times 3 is 9. Then I move on to my same bases. We know that when multiplying with the same bases, we add the exponent.
Yes.
So x squared times x would be x cubed. And then y squared, we don't have another y. So it would just be y squared. And then I found my product. Makes sense?
Numbers of the same base just add each other.
When you say numbers with the same base, you mean the 3 and the 3?
3 and the 3, so the x is added to the x, and then the y is single, so it goes by its own. That's what you're saying.
Exactly. Okay. And just remember these coefficients, so the 3 and the 3, they follow the operation that we have. So it's 3 times 3. It's not 3 plus 3.
Okay,
good. We are going to do some examples where we deal with all of this. So, but yes, that's essentially how we deal with that.
Okay, I understand.
Oh, sorry, hang on. If you were asking me another question, you're going to have to unmute yourself.
Oh, I'm done.
Okay, cool.
I'm done.
Cool. Umlemo?
Ma'am, can you hear me?
Yes.
Ma'am, where you've written a coefficient, the last line. So OC stands for coefficient, but in short.
The last line, are you talking about this bit over here or this bit?
That one, the second one.
Sorry, that's supposed to say x to the power 4. So if we go to the coefficient of x to the power 4, that's 3.
Okay, thank you, ma'am.
Sorry, my writing went a bit weird there.
Yes, ma'am. Thank you, ma'am.
Pleasure. Right, last question. Unati? Unati, you there? There should be a pop-up to unmute yourself. Okay, ask your question on the...
Yeah, you can ask it on the chat, but they should be on your mic. Just press there and you definitely can talk to us. It should be a pop-up that you need to press on. But you can also put on the chat and then we'll be able to help you. A pop-up
Oh, there we go.
to press on. You can also put on the chat and then we'll be able to help you.
Oh, there we go.
Oh,
we go.
ma'am, can you please? Ma'am, I don't understand.
Here we go. What
I don't
you
understand.
What don't you understand?
Yeah,
What don't you understand? What don't you understand?
Ma'am, can you please explain for me the terms?
Okay, so
I don't understand it.
Okay, so terms are parts of an expression. So they are the individual parts that make up an expression. So 3x to the power 4 is one of my 4 terms. So the plus and the minus signs separate my terms in an expression, and then I'm dealing with individual terms. So terms are almost like the words of our mathematical sentence that is an expression. Does that make more sense?
Nati, you are now muted again. So you can either, I'm gonna try and unmute you, but you can either put it on the chat and then we'll be able to help you, okay? And also just know that we are recapping. So if you still don't understand and everything, don't worry, we'll try our level best to make you understand. But I'm just mentioning it that we are recording the lesson, okay? So you are allowed to rewatch again.
Yeah, I think there's a bit of a delay.
Yeah. So it will be good to rewatch again the lesson. But yes, you're doing really well. And teacher Sam also, she's so patient with you guys.
All right, guys, last question. Kani? There should be a pop-up to unmute yourself. Oh, there we go.
Hey, ma'am.
Hi.
I don't understand this one. X to the power of 4 equals to 3.
Okay, so for that one, this was just an example. We were talking specifically about the coefficient. So if I'm asking you for the coefficient of the term x to the power 4, if I go back to my original expression, x to the power 4 has the number in front of it, has the coefficient of 3. So I'm just sort of answering a question for myself.
Oh, okay. Thank you, ma'am.
Pleasure. Alrighty, guys. So just remember, we have done all of this before. So if you are still feeling a little bit uncomfortable, we did an algebra course I really want to say at the end of last term. So all of those videos are on Watobe's website. Go and have a look at them. Alrighty, so let's have a look at an example before we have a bit of a break. And this is basically going to hopefully answer and help with any confusion that some of you might be having. So here we've got an expression. Let's just look at what expression we've been given. It says, consider the following expression, and we have been given minus 2x squared plus 3x cubed plus a third. Okay, so automatically, guys, you should be thinking of, do I have a constant in my expression? How many terms do I have in my expression? What is the biggest exponent of my expression? Can I identify coefficients, etc., etc.? So if we have a look at our first question, it asks, how many terms does this expression have? Now remember, in our definition, we said that terms are separated by plus and minus signs. So here we've got a plus, here we've got a plus. Yes, we've got a minus there, but there's nothing in front of it to worry about a separate term. So I've got the plus and the plus, and this is telling me that I have got 3 terms in my expression. So well done, those of you who put it on the chat. This expression has 3 terms. Now, I know some of you like to write out the expression has 3 terms, but this is maths. We don't need full sentences unless the question says explain your answer or justify your answer, whatever. 3 is good enough. That tells me you know that there's 3 terms. All right, just on the chat, I'm not sure why people can't see the X. You might need to log out and log back in again. Offense said, does the coefficient and the terms correspond with each other? I don't really know what you mean, but a coefficient does make up a term. So I hope that helps in clarifying. So for example, in the first term, that is made up of a coefficient, a variable, and an exponent. So coefficients make up or can be part of terms. Okay, right, so guys, we have answered the first question. We've seen that we have 3 terms because of those plus and minus signs. I've been able to separate my terms. The next question asks, what is the degree? And I can't spell of apparently. See, this is maths, not English. What is the degree of this expression? So all you want to do is look for the biggest exponent of your variable. Now, the only variable you have here is x. All right. So look at your x terms, which one has the biggest exponent and what is that biggest exponent? So quickly on the chat for me, tell me what the degree of this expression is. Guys, there's some of you on the chat that I don't even know where you're getting things from. Minus 2 is not a term. Minus 2 is a coefficient of x squared. The whole thing, minus 2x squared is the term. Remember, I just said coefficient is part of a term. You can have a constant, which is a number by itself, but it is no longer then a coefficient. So let's just focus. And if you are confused, please try and be very clear about what your question is. Okay, whoops. Right, very nice, guys. We can see that the biggest exponent here of x is cubed. So the degree of this expression is 3. Again, you don't need to write out the degree of the expression is 3. Just put down 3. That's good enough for us. Right, so hopefully those of you who are a bit confused about the whole minus 2 coefficient constant thing, this next question is going to help. The next question is asking you, what is the coefficient of x squared? So remember, coefficient is the number in front of. So this is asking us, what number is in front of x squared? So if we go up to our expression, here's x squared. The number in front of it is negative 2. So the coefficient is negative 2. And again, the coefficient is part of or makes up the term negative 2x squared. Alrighty, the last one is now one we like to often ask with these sorts of questions, whereby we now give you a value of the variable and we ask you to find the value of the expression. So now I'm saying determine the value of this expression if x equals negative 2. All right, so guys,
Okay,
like
it's
I
fine
said,
now. Success, sorry.
awesome. No, perfect. So guys, like I say, what we often like to do is we like to ask you questions like how many terms, coefficient, degree, what is the constant term, blah, blah, blah. And then we like to ask you, work out the value of this expression if x equals whatever. So what you need to realize is that I'm giving you a value for x. So So what this means is that every time I see an x in my original expression, I now need to substitute in positive 2. So if we go and have a look at that, we are going to say negative 2. Now we're going to substitute in x equals 2. So times 2 squared plus 3 times 2 cubed plus a third. Now, often we'll ask you to do this without a calculator. So this is also good practice of being able to simplify these sorts of expressions. So remember, guys, if you're going to do this, you have to follow bodmas. You know that I'm not a huge fan of bodmas. I use bedmas, but it really doesn't matter. Again, I don't know why I keep choosing this rainbow pen, but whatever, we're just going to roll with it. First thing I have to deal with are my exponents. So going back to my expression, I'm going to leave the coefficient negative 2 there. I've got no issue with it. I'm just not going to deal with it right now. I'm now going to deal with the exponent. 2 squared is 4. Now remember, between a coefficient and the variable, it's multiplication. So this is negative 2 times 4 plus 3 times now 2 cubed is 8 plus a third. No hands, grade 8s. If you have a question, put it in the chat. Then we go and deal with, so we've dealt with the exponent. Now I deal with any division or multiplication. I've only got multiplication, so I go and deal with that. Negative 2 times 4 is negative 8. Positive 3 times 8 is positive 24. And then I've got my plus a third. Now we need to start adding and subtracting. So I'm gonna make my life a touch easier. Minus 8 plus 24 is 16 plus a third. Now at this point, I'd probably just put this on my calculator because I'd be lazy. But if you have to do it without a calculator, remember when you add or subtract fractions, you need an LCD. Guys, I appreciate you saying sorry I'm late, and I get it, these things happen, but please don't spam the chat with that. If you're late, catch it up. Bedmas, brackets, exponents, division, multiplication, addition, subtraction. E is exponents. It relates it directly to O, which is order, which means exponent as well. I prefer bedmas because E to me means exponent better than O. Right, so I need an LCD here. My LCD is 3. So that means I'm going to have 16 times 3, whatever that is. This is why I'm saying I'll probably just put this on my calculator. 16 times 3 is 48. So this would be 48 over 3 plus 1 over 3. And I'm just going to write my answer here, 49 over 3. Now, if you can simplify your fraction, do it by all means. But in this case, we can't simplify that further. We leave it as it is. Lisa, we can't add the exponents. No, because you're not multiplying. We only add exponents when we multiply. All right, I'm staying here. Take your screenshots. We'll take a quick break and then we will continue onwards.
Yes, my people. And I've figured out something that we can all try it out. Basically, when Teacher Sam is busy teaching, no one has to be asking any questions. And then when she's done, she will give us an example to do. And we do it one by one, okay? And then if you have any questions, however, after the corrections of that specific question, then we can start asking questions, okay? Because I see that some of you are asking for other work that is more than what we're doing today, in a way. So we're gonna do it in a much more, let's see how it goes. Sorry,
And
Teacher
guys,
Sam. That's what I think.
No, because guys, remember also Yolanda start this lesson saying this is revision of what we have done.
Yeah.
So if you're not understanding this, we've done this. So for those of you that are new, like I said, go and watch the videos. I can't reteach a course that we've already taught, but it also just means you might need a bit of a refresher, which is absolutely fine. But go and watch the videos. They are there for you. We're going to move on to new stuff, and then we're going to talk about all of these multiplications and all the rest of it, but we're getting there. I don't know, there's a saying, you can't run before you can walk. Just hang 10. And exponents as well. We have done an exponent section. So when it comes to adding exponents and minusing exponents, we've done that. Go and look at the videos.
It's already done and dusted, my people.
Exactly. All right, brain break. Here we are. Something a little bit different today. You have to guess. Oh. You have to guess the saying. Lisa, how is 2 times 3, 8? It's not. I'm not too sure where you're looking, but if you are looking in this first step, you might just be misreading here. If it's a first step, 2 squared is 4. -2 times 4 is -8.
I think it's more of the second
yeah,
that
the
we
second
read
thing you
about.
then are struggling to understand the exponent, so go watch the exponent sections. 2 cubed is not 2 times 3. 2 cubed is 2 multiplied 3 times. So 2 times 2 times 2, that is 8. So just be careful. Yo, okay, it's your phone, that's fine. Right, brain break. So a little bit different today. You've got 4 sort of pictures, and you need to tell me what the saying is for each of those pictures. I put numbers there, so you can, on the chat, you can write 1 answer, 2 answer, 3 answer, etc., etc. Try and do all of them at the same time, and then let us know what you think the saying is. But let's see how you go. I'm not going to give you very long. Let's say like 2 minutes. So put 1, what do you think it is, and so on.
Let's go, my people. Let's go. And we have the joke here. What tool is best suited for math? Multipliers. I think it's the best joke. Yeah, basically we just you see like frame number 1, you need to guess what the word is. I'm really horrible at this, guys, so I don't even know if y'all are saying the right thing or not. But I'm very, very terrible at it. So I see majority of you are saying number 1 is fast. But it doesn't look like it's fast, guys. Number 1 is not.
Sorry, I'm just... Okay, and grade 8. I'm fully aware that I'm someone who sometimes gets a bit frustrated. But please, if I answer your question, A, don't argue with me. Like, I'm pretty sure I know what I'm talking about. And if you really don't agree, let's do it politely. And secondly, please, when I'm explaining something, like Yolanda was saying, let's listen, because otherwise I'm wasting my time and I'm wasting your time.
Let's go, my people. I think I saw someone said something about 2, teacher Sam, and I think I don't agree with them because they're missing the important part. Everyone who's saying turn on number 2, you're missing, you're missing the important part. I think that's the only one that I can actually know that y'all are missing something. Yes, teacher Sam has just teacher Sam has hooked me up, guys. So I know. Okay, so I think
you are getting 1 now.
Olondo has got number 1. So number 1 is breakfast. Well done, Olondo. I don't know who else wrote that. Yes, it was Olondo. Nice, Olondo. Nice. Let's see. I think most of you have gotten 4 also. Let me see. I might be lying, but at the top, I think I saw something that was like that.
Laura got number 3. So 3 is top secrets.
And Olondo also got number 4. Once upon a time.
Nice.
Olondo, you're good at this. Orlando is nailing this, guys. Let's go. Let's go.
So we're just missing 2.
Let's go. Sebo, you must put it on the chat, Mugai. So it's not time to raise your hand. You must put it on the chat.
And if
so
you have
can
questions,
see.
put them in the chat as well.
Teboho 4 is already found, eh, guys? So remember, 1 is breakfast, 3 is top secret, 4 is once upon a time. What's 2? Let's go, guys. What's missing in that turn? And then now I've given you something to work on. Let's go. Guys, they are so fun to
Okay.
do.
Okay.
Yes, available.
Okay, so guys, number 2 is no U-turn because it's a turn without the U, so there is no U-turn. So well done. Everyone else, just though it seems like you guys got the others. The no U-turn was a little bit tricky, but well done. You guys are much better at this than I am. Also, I'm like Yolanda, I'm not great at this. I generally have to Google it. Tatenda, I'm so sorry. I did not see the no U-turn, if I'm being honest, that you sent through. Scrolling up to see where.
And well done, guys. Remember that sometimes we really can't see, but really, if you did get first, it's good to tell us that you got it first so we can congratulate you. So
I
well
still don't
done,
see it. Maybe
people.
I'm losing my mind.
I also didn't see it, but well done.
Well done, guys.
Guys.
Okay,
Yeah,
so we are.
awesome.
I'm jumping to example 3 just because a lot of you have been asking questions around this, so we're just going to have a look. But again, grade 8s, we have done this. If you don't remember any of this, go and find the videos. So here we want to simplify these expressions just before we start anything. Remember, we're now back on work, so our brain break is over. We're back to the work, so make sure that we're focused and answering the questions and asking questions based only on this. So we've been asked to simplify the following. Please don't do B yet. I'm not asking you to do B. We are doing this together to start off with. So this is now where bedmas and understanding terms is very important. So for A, what I see is that I've got -3, that was just gross, times the bracket. So what that means is that this entire thing is one term. Yes, inside my bracket, I've got 3 terms, but the whole expression is one term. I now need to ask myself, okay, can I simplify this term in any way? Because right now, whenever we see brackets, it generally means that we need to do something. So what we need to remember is that when we do see brackets, it generally means distribution. So what I now need to do is I now need to take this -3 and I need to multiply it to every single one of those 3 terms inside my bracket. Now, guys, please remember to be very careful and very wary of your signs. So if we start with -3 times x, negative times a positive is a negative. 3 times, now remember there is a coefficient of 1 there, so 3 times 1 is 1. And then we have the x. -3 times -y, and negative times a negative is a positive, 3y. -3 times -2, again, a negative times a negative is a positive. And 3 times 2 is 6. So what that means is when I go and simplify this expression, I end up with the simplified expression of -3x plus 3y, because remember, negative times a negative is a positive, plus, same reason, 6. Now, once you've distributed, you always need to check for any like terms. So check for like terms. Remember, like terms are ones that have the same variable and the same exponent. In this case, I don't have any like terms. I've got different variables and then I've got a constant. And so what that means is that this is my final answer. So those of you asking me, is this the right answer? Is this correct? What I've written down is the correct answer. And again, I didn't ask you to do it. You should have been following with me. So there should be no questions about what's happened here. So we've distributed, we've double checked to see if we have any like terms. We didn't have like terms. So now our expression is simplified. Okay, so when we have a distribution or when we've got brackets, we need to remember that means multiplication. I just quickly, Taboko, whilst your answer is correct, please try and not have 2 signs next to each other. So there where it's plus minus, we know that's a minus. Please write it as a minus. And same thing for the plus minus 6. Again, your multiplication's a bit weird. Those should both be positives, and you need to look in this red block here if you're not too sure why. Guys, please, hands. I haven't asked for hands yet. All I've done is explained a question. That's it. Please just hang on. I'm still trying to finish sentences. I'm still trying to clear up confusion.
Yeah, and also I just feel like when you're busy writing on the chat, guys, you're losing the content of what Teacher Sam is saying. My people, we need to listen to the whole thing, because what you're asking, maybe she's about to explain, but you're already asking questions about it.
And grade
Okay.
8, what I've written down is the answer. It can't be something else. So please don't tell me, oh, is it 3x? Is it 6-2? Whatever. What I've written down is the answer. It can't be anything else. The only thing that can change is the order. So if you wrote 6 minus 3x plus 3y, that's fine. You've shuffled the order, but those 3 terms have to be there. End of story. There's no debate about it. That's it. So please, if you're not going to listen, then like I said, I'm just wasting my time, and then we might as well all just end this early. Okay, so brackets means distribution, means multiplication. If you need to do a little multiplication block like what I've done over here, do that, because you need to make sure that your signs are correct, as I have already stated. Right, so now at this point, if anyone has any questions, please do raise your hand and ask me. Ole?
I just wanted to just double check something. So if a negative is outside of the bracket, so everything, and you're saying like the sum A, so then it changed into positive numbers because the negative affects the the equation in the brackets, right?
Yes, exactly. So like you've said, this negative is attached to the 3. So we are distributing in the entire -3. Good.
So then the negatives in the brackets will turn into positives.
Exactly. Well done.
Okay, thank you.
Good. Okay, grade 8. I'm just about done. No, it cannot be anything other than what I have written down there. So minus 3xy6 is not correct. You have not got your separate terms there. And that is the last I'm going to say on it. BK. Don't look so
Okay,
scared.
ma'am. I'm a bit scared, ma'am. Yo, ma'am. So I want to make another example, ma'am, right?
Okay.
So if, like, I get confused with the negative and the positive, you know. So like I know you have to times the -3 with every single thing out inside the bracket, right, ma'am? So what if we do something like the x is like the x says -26. I get confused with that also.
So -3 and then -26 minus y,
Yeah.
something like that.
Yes, ma'am, like that.
Okay, cool. So when we distribute, we are going to have -3 times -26. Now this is a negative times a negative. So we have a positive. And then we've got 3 times 26, which you're really testing my math here. I'm pretty sure that's 78, but I'm just going to double check myself. 78. So this is positive 78. And then we're going to distribute to the y as well. So -3 times -y, negative times a negative is a positive. 3 times y, 3y. So when you put these together, you end up with a simplified expression of 78 plus 3y.
Oh.
Okay, so whenever there's a negative times a negative, like Ola was saying, the signs change. So negative times a negative is a positive.
Like for example, okay, let me make another example, ma'am. What if the 26 was a positive, ma'am?
Okay, so if it was positive, then it would be, let's just get another color here. So this was positive 26. Then it would be -3 times positive 26. But a negative times a positive is now a negative. So then it would be -78 plus 3y.
Interesting.
Okay, so guys, just
sorry, I'm just gonna run the poll if you don't mind while we're busy taking the questions.
Yeah.
Let's see the poll, guys.
Okay, so guys, just quickly on that, just as a summary of your signs, negative times a negative positive, positive times a negative negative, negative times a positive is also negative, a positive times a positive is a positive. So you just need to bear that in mind when you are doing your multiplication. Right, there's 3 more people with hands up. Oratile, Elixa, and Omolemo. Those are the last 3 questions I'm going to take. Everyone else should be doing the poll. Oratile?
I wanted to confirm my suggestion. Is there any step that you can use to find the answer quicker or anything that you know of? And is -3 and 3 numbers of the same base?
Okay, so in answer to your first question, can you do this quicker? This is pretty much as quick as it gets. You can ignore the red blocks. You don't have to do the working out of the multiplication. You can go straight to the answer, but that's pretty much it. Then in terms of your -3 and +3, yes, technically those are the same base, because -3 and 3, what you need to remember is that can be broken down to -1 times 3, which essentially means that you're working with base 3s.
So that meaning numbers of the same base can be multiplied or added together, right?
Yes. Well, any numbers can be multiplied or added together, but this I could now write as -1 times 3 squared. I could add the exponents together, so I'd have -9.
Okay, that makes total sense.
Good. Alexa?
While Alexa is unmuting, I hope that Uradile didn't mean that we sorry.
Yeah?
So, ma'am, could I please ask, why can't we add in the final answer, ma'am, why can't we add the 3s, ma'am?
Because they're not like terms. This term has an X, that term has a Y, they're not like terms.
Okay, ma'am, thank you. Also, ma'am, could I please ask, in the brackets, ma'am, the subtracting sign, ma'am, does it show that the Y is a negative or positive?
I mean, it shows both. So it shows that Y is negative. It also shows that we are subtracting Y from X, but it is a negative Y.
Okay, ma'am, thank you.
Okay, not all of you have answered the poll. Please do it. Omolemo, last one.
Ma'am, am I loud enough? Can you hear me?
Yeah.
Okay. So, ma'am, the X and the Y, what do we consider them as?
Those are variables. So those are our unknown values that we're working with in our expression.